Okay, let's do two more examples that require the chain rule. And I am going to use the U idea sometimes that I was complaining about in the last video. U will represent the inner function just so it makes it easier to understand what's going on here. So in this first example, we're going to do two of them here. We're going to differentiate the trig function y equals the cosine of x squared. So the argument is x squared. We're not squaring the entire cosine. We're just squaring the argument x. Let us proceed. Example solution. The inner function in this problem is g of x equals x squared. That's our u, inner function. The outer function is f of u, which is equal to the cosine of u. So it's f of g of x. Okay, then the derivative of y with respect to x is a derivative with respect to x of the cosine of parenthesis x squared. So that's equal to, okay, what's the derivative of cosine? It's negative sign, but it's not of x, it's of x squared. That's f prime of g of x. Now times, don't forget to times, that's a chain part. The derivative of the inner function x squared is 2x. That's g prime of x. So we have the outer function evaluated at the inner function with respect to the inner function times the inner function derivative. Next example, differentiate y equals cosine squared x. That's different. Here we're squaring the cosine, not the argument, but the actual cosine. The inner function in this example, g of x, is cosine x, and the outer function is f of u equals u squared. So it's a square. All right, then the derivative of y with respect to x is d dx of cosine squared x, which is the same as d dx of parenthesis cosine x squared. That's a definition of square of a trig function. Okay, use a power rule. 2 times the cosine of x, that's f prime of g of x, times the derivative of the inner function, times, times, times. So multiply the derivative of cosine, it's negative sine. Oh, completely different than the other example. So our answer is negative 2 sine x cosine x. Okay, so just stop and think about this for a while. The first example, we were squaring the argument x, and when we applied the derivative of the outer function with respect to the inner function, it was a derivative of cosine, which is negative sine, evaluated at the inner function g of x, which was x squared. And then we multiplied that. They say you hit it. That means you multiply it. We hit it with the derivative of the inner function, the derivative of 2x squared, which gives you 2x. We brought the 2x out in the front. There was our answer. Now, for the second example, now our inner function was the cosine of x, while our outer function was the square function. So you know what happened here? These dudes traded places. If you look at the first example, the inner function was the square function, while the outer function was a cosine function. In this example, the inner function is a cosine function, while the outer function is a square dude. Okay, so what do we do here? Don't think too hard, okay? What we did is we took the derivative of the outer function, which was a square function, with respect to the inner function. So it was the square function, so we brought the exponent 2 out in the front, times the cosine of x raised to the 2 minus 1, which would be the first power. So we get 2 times the cosine of x. Then we multiply it by the derivative of the inner function, which in this case was the cosine of x. So the derivative of cosine of x is negative sine x. Multiply that together, we get our answer, negative 2 sine x cosine x. Okay, now if you've uncrossed your eyes, go back and look at this and try to make some sense of it, because it's really good to see the difference between these two.